All right, so first one, female. Probably a female. Angela, what'd you get? 15 over 40. Okay. So yeah, 15 out of 40. And Dom L. What'd you get for female given chocolate?
3 over 8.
3 over 8. Good. So if you simplify those out, using your calculator, you'll get 0.375. Oops. So, are these independent or dependent? Independent. And again, if you look at it, you'll see they make the 4 things that you care about. Guys, heads up. You have an exam in 9 days. The 4 things you care about are circled there. They make a rectangle. All right, so you can either do 3 over 8, 5 over 40, or you can do 3 over 15 and 8 over 40. Either one. Either both going to be equal or they're both going to be not equal. In this case, they're both equal. So on the exam, you will tell me you're independent. You want full credit. Because 3 over 8 is equal to 15 over 40. Done. Good? Okay. Hey guys, try not to talk when I'm talking or other people are talking. The reason I used to not care about that much, but then I got people giving feedback on my thing saying, hey, so-and-so's talking, it was really distracting, I couldn't learn because they were talking. So the thing about it is, people have paid money to be in this class, and it's not fair if they can't learn because you're distracting them. Does that make sense? So if someone's talking near you, it takes your mind, part of your working memory, away from focusing on what you're trying to focus on. So yeah, it's just wait, because it's not like 5 minutes later I'm not going to give you a chance to talk to your neighbors, right? Okay. If it's like a quick 5-second thing, that's fine. But if it's longer than 5 seconds, then it's trouble. Okay. All right. So again, I told you I'd talk to you about these multiplication rules. Probably A and B. And means multiply. If they're independent, you just multiply their probabilities. Done. Piece of cake. If they're dependent, then probability of A and B is probability of A times probability of B given A. So probability A times probability of B, but B given that A has happened. So I like to think about it as if I'm going along this in a tree, probability of A, so I take a step towards A. Now I'm on A. Now, given A has happened, probability of B given that A has happened. Does that make sense? And you multiply those two probabilities. All right, so that's why you do that. Future probability, probability of B given A, again, that line straight up and down is given A, means probability of B given A has happened. So again, just like a tree, I think of probability of A. Now I know I'm at A. Now, given that A has happened, the probability of B. Probability of B given A has happened. Okay, someone else from one of my classes pointed out something kind of cool, which I forgot to mention. Where should I mention it? Here. Right. Female given chocolate. So this will come up, female given chocolate. She pointed out that people always remember the female given chocolate. They remember the numerator. The numerator part is the female and chocolate people, the 3. Up there. They don't have a problem with that one. They have trouble figuring out what to divide by. Do I divide by 8? Do I divide by 15? Do I divide by 40? The way that she figures it out, she said the easy way to think about it is this looks kind of like a division sign, kind of like this, right? So you're dividing by the total of chocolates. What's the total of chocolates? 8. So it's going to be 3 over 8. So that's kind of that neat trick that someone a few years ago put it out. She's like, Ms. Young, just kind of think of it like a division sign, dividing by the total of whatever you're given. Good? So great tip, keep that in mind. All right, so lab number 8. Coin is flipped and die is rolled. Draw a tree for this. The first event is flipping a coin. So first you're going to flip a coin. How many options are there if you flip a coin? 2. Great. Then from each of those branches, you're going to roll a die. So from each of those branches, you will roll a die. How many options do you have for that? 6. All right, go to it. Okay, so my options are heads or tails for my coin. And then if I get a heads, I roll a die. I have how many options? 6. 1, 2, 3, 4, 5, 6. If I roll the tails, if I flip the tails, then I roll a 1, 2, 3, 4, 5, or 6. Good? So then everybody write out your sample space. Write your sample space if you haven't already. Here's your sample space, yes? And then I want you guys to do this. On your, so your tree probably looks more like this. Oops. Uh-oh. Oh, I know why. Okay, hold on. Okay, so on each of the, what's probably I get a heads? 1/2. Tail?
1/2
Tail?
also.
1/2 also. So on the branch itself, I want you to write in the 1/2. Actually, physically on the branch itself. Just like that. And then probably rolling a 1, 2, 3, 4, 5, or 6. 1/6. So on those branches also, I want you to try to fit in a little 1/6 on there. I know you guys, a lot of you guys didn't live in a lot of space, but just do your best. So what I asked for, so if I asked you probably rolling a heads and then, sorry, flipping a heads and then rolling a 4. Heads and then a 4. So first I go to heads, then I go to 4. All you need to do is take the probabilities along those branches, the 1/2, multiply it by the 1/6. Just as you go along the tree, you just multiply the branches. So the probability of rolling flipping a heads and rolling a 4, 1/2 times 1/6. When I multiply fractions, you'll need to know this, multiplying fractions. When you multiply fractions, you multiply the numerators, the top, that's your new top, and you multiply the denominators, the bottoms, and that's your new bottom. So 1 times 1 is 1, 2 times 6 is 12. Good? But also, we know, we figured out earlier, these are independent events. So, since they're independent events, we can just take the probability of rolling a heads, 1/2, multiplied by probability of rolling a 4, 1/6, and you get 1/12. You can also solve it using sample space, right? You guys have all written down your sample space. How many items are there? 12, all equally likely. How many are heads and a 4? 1, so 1 out of 12. You can solve it that way as well. Trees are super helpful, especially when probabilities are not the same. So here I've got, this is not yours, this is mine. I have 3 red marbles, 6 blue marbles. I'm going to draw 2 marbles with replacement. So I first draw red or blue. What's probably I draw a red one? Nope. I have 3 red ones, I have 6 blue ones. 3 successes out of how many? 9. How about blue? 6 out of 9, great. Now, I replace it. I draw it, and then I put the marble back, the same marble back. And I draw again. What can I draw for my second draw? What can I draw? I draw a marble, what could it be? Red or blue? red or blue. Again, probability of red is going to be 3 nights because I put it back. And probably blue is going to be 3 nights because I replaced it, right? If I do a blue marble first, then what can I draw for my second marble? Red or blue. And again, 3 nights for red, 6 nights for blue. Good? So if I want to find the probability of drawing a red then a red, I just multiply the probabilities. Blue then red, 2/3 times 1/3, 2 nights. Blue then blue, 2/3 times 2/3, 4 nights. You just multiply the probabilities as you go along the tree, along the branches. So here's all of them. Right? So that's just, you can find all of this. And the interesting thing is you'll notice is that if I look at all these possibilities, 1 night plus 2 nights plus 2 nights plus 4 nights adds up to 9 nights. Adds up to 1. All of them will do that. Every set of branches, the total sample space, so from here, that branches, that adds up to 1 or 100%. Those total outcomes add to 1 or 100%. These ones add up to 1 or 100%. Anytime you start off with something and you branch off, it better add to 1 or 100%. Okay. This is a little bit confusing. I like to think of it as a river flowing. So I'm in this river, I'm flowing along, and the river branches. 1/3 goes to red, 2/3 goes to blue. I go to the red branch. Now I'm in this red branch, and the river branches again. 1/3 to red and 2/3 to blue. But it's not 1/3 of the whole river. This is 1/3 of the river because I already branched, right? So if you look at it, you see I branch, it's only 1/3 of the river, and again 1/3 of that. So it's 1/3 of 1/3. Of means multiply. If I buy 3 of these are $10. I don't pay 3 plus $10, I pay 3 times $10, right? So of means multiply. So 1/3 of 1/3, 1/3 times 1/3. Again, 1 times 1 is 1, 3 times 3 is 9, so 1/9. Good? So this kind of hopefully helps you kind of wrap your head around that. So you guys, you do lab problem number 9. There's 3 red marbles, 1 green marble, 6 blue marbles. So you're going to have 3 different branches coming off. Make them big branches. You need to draw a tree. What's the probability you have to draw a tree for your exam? 100%, exactly. So draw a nice big tree for yourself and put in your options. So your first one should look something like this. Red, green, blue. What's the probability that I draw a red one? Chloe?
310.
3 out of 10. Probability that I draw a green one? Lindsay?
1 out of 10.
1 out of 10. Probability I draw a blue one? Dominic?
6 out of 10.
6 out of 10. Good. Right, so that's what you should have. I want well, your goal at the end of the branch, right? Blue, green, or red at the end. Your probability along the way on the branch. It just makes things easier for you. Now you draw the marble and you put it back. So then my second draw, what could I get from my red? If I drew a red first, what can I get for the second draw? A red or blue. And then what are the probabilities? Write them on there, and then figure out the rest of them as well.
This should be turned on.
Oops, yeah. Darn screen. Let's take a look. So for your second draw, you can get red, green, or blue for any one of them. Since I replaced the marble, then my second draw is going to be exactly the same as the first. So probably red is going to be what? 3 to 10, green, and blue. Yep. So you should have all those in there. Now, what are the questions? The first question was, what's the probability you draw a red for your first marble? Yeah, so A is going to be 3 out of 10. 3 chance that you draw red first, yeah? Second question, B, was, what's the probability that you don't draw a red for your second draw? Your second draw is all the same. So what's the probability you don't draw a red? 7 out of 10, the green plus the blue, right? So it's 1/10 plus 6/10, 7/10. Or you could do 1 minus 3/10, either way. All right, last question was C, red then blue. What's probably I go red, and then I go blue. So you're going to multiply along the way. So I'm going to have 3/10 multiplied by 6/10. And again, when you multiply fractions, you multiply the numerators. So 3 times 6 is 18 on top. You multiply denominators. 10 times 10 is 100 on the bottom. So you will need to know how to multiply fractions like that. So make notes if you need to. So 18 out of 100. Good? Yeah.
So for the test, should we be simplifying or dividing for decimals?
Nope.
Or
Don't. Just leave them like that.
just raw? Okay.
Yeah. Yes.
So if you were to remove the marble, wouldn't the probability for the second round, so like say you get
It would
red-
change if you didn't replace it.
Yeah,
but
so
we
it would be
replaced
like,
it.
So it would be like 2 out of 10 instead of 3 out of
Even though it would be 2 out of 9.
Oh, 2 out of 9, right.
Because now you have if you did not replace it, you have 2 out of 9 marbles. Yeah. Go ahead.
For the second one, no trick on second.
Yep.
We have to ignore the 3 out of 10, and we can go for 1 out of 10 and 6 out of 10.
Yep. And add them. So it's either this one or that one. Or as we,
And
or as we what, guys? Or as we add. I'll try it again. Or as we add. So green or blue, 1/10 or 6/10, you're going to add them. So
And we don't have any work with the 6 out of 10, with the first branch.
don't worry about the first branch because it's the second draw.
Okay.
Yeah. Yeah, I'm just saying on the second draw. Yeah. Okay. Good.
You got a screen
Yeah.
down.
I know the doggone screen. Okay. So we have a second example. It is I'm warming up hopefully. A Harris poll found that 46% of Americans say they suffer great stress at least once a week. I don't think this is on your example. I think it's just on mine. So if 3 people are sampled, can you guys see that far one over there? It's kind of hard, but do your best to look at it. So it's what it's saying. 46% of Americans say they suffer great stress at least once a week. So that means that I'm picking 3 people at random. What's the probability that she suffers great stress at least once a week? 46%. What's the probability that she suffers great stress at least once a week?
46.
What's the probability he suffers great stress at least once a week?
46.
46% chance. Okay, good. But now I want to find the probability that she does, and she does, and he does. Is that harder or easier than just one of them? Harder, because they all have to. Do you see what I'm saying? And means they all have to, so it's harder. So when we multiply numbers that are smaller than 1, it makes your number smaller. So and means multiply, so 46% times 46% times 46%. Right? First person, second person, third person. You're going to get 0.097, a lot smaller. Right? Because they all have to happen, so it's going to make that probability smaller. Please note that's like replacement because even though we did not replace the people, we picked 3 different people without replacing them. How many Americans are there?
360-something million.
Yeah, 300 and something million people, right? 300 and something million. If I take 3 or 10 or even 100 or 1,000 out of 300 million, is that going to change the percent at all? No, that doesn't affect the percentage at all. So whenever you have a large group like out of all Californians or out of all Americans or out of all people or all whatevers, then if it's a large group, then this percentage is not going to change if you take a handful of them. Does that make sense? So it's just like replacement because it's big. All right, so you guys have a problem to do now. Here's your problem, problem number 10 in your worksheet. Automotive sales. So she's trying to make a sale. Talks to 4 customers. So it's probably the first one buys, and the second one buys, and the third one buys, and the fourth one buys. They all buy. Is that likely or unlikely to occur? All right, guys, what's probably the first person buys? 20%. What's probably the second person does? Third person. Fourth person. Now I need the probability that the first one does, and the second person does, and the third one does, and the fourth one does, and we multiply. Thank you. Try it again. And we multiply. So we're going to do what to these? Multiply. What do you guys get? 0019. Okay, so we get 0.0019. Is that right? Or is that too many zeros?
Oh, that's right.
Okay. Is this likely or unlikely? Unlikely. What's our general guideline for unlikely? 5%. 5% or less. This is 5% or less, so it's unlikely. Right? Unlikely. It is 5% or less. Everybody on board? Okay. Now we're going to jump to flip to the next page and the very bottom of the next page, where it says complement rule probability of A. We're going to jump to that because you have an exam in 9 days, and I want to make sure that we cover this. Oops, wrong one.